Practically every industry requires a certain amount of work to be done above ground level. Often, when work is performed in elevated locations, portable ladders or scaffolds are used. Ladders and scaffolds are designed to help workers reach areas that are ordinarily out of reach. However, since they enable personnel to work at elevated heights, both ladders and scaffolds can pose a safety hazard if they aren't used properly. Ladders are a common sight at many industrial facilities and construction jobs. A number of different types of ladders are available. The specific type that's used depends on the job being done. Three basic types of portable ladders are straight ladders, extension ladders, and step ladders. A straight ladder is the simplest of the three basic types of ladders. It consists of two rails with crosspieces called rungs between them. The rungs are used as steps to climb the ladder. At the bottom of the rails are safety feet, which help prevent the ladder from slipping when it's in use. An extension ladder is basically an assembly of two overlapping straight ladders. The amount of overlap between the two sections can be adjusted to change the overall length of the ladder to match the needs of a particular job. The third type of ladder is a step ladder. It's a self-supporting portable ladder that's made up of two sections hinged at the top. The section that's used for climbing consists of rails and rungs similar to those found on a straight ladder. The main difference is that the rungs on a stepladder are actually flat steps. Safety feet at the bottom of the rails help prevent the ladder from slipping. The other section of the ladder consists of rails and braces. The braces are designed to support the rails. They should never be used for climbing. Hinged arms, called spreaders, located between the two sections, stabilize the ladder and prevent it from folding up while it's being used. When a stepladder is properly positioned, a stable triangular shape is formed. Besides being available in different materials, ladders also vary in size and load-bearing capabilities. A standard rating system is used as the basis for dimensions and weight limits. The rating system classifies all portable ladders into one of four basic categories or types. One category is type 1A. Ladders in this category have a maximum load-bearing capacity of 300 pounds. Type 1A ladders are suitable for extra heavy-duty applications, such as those found in industry, utilities, contracting, and so forth. The second category is Type 1. Type 1 ladders have a maximum load-bearing capacity of 250 pounds. Ladders in the Type 1 category are used in heavy-duty applications, similar to those for which Type 1A ladders are used. The third category is Type 2. Ladders in the Type 2 category have a maximum load-bearing capacity of 225 pounds. Type 2 ladders are medium-duty ladders commonly used in offices for light maintenance and in similar applications. The fourth category is Type 3. Type 3 ladders have a maximum load-bearing capacity of 200 pounds. Ladders in the Type 3 category are light-duty ladders typically used for light household jobs. Ladders are commonly used to enable personnel to work in elevated locations, but anytime work is performed above ground level, there's an increased risk of an accident. To reduce the chance of an accident associated with using a ladder, some basic safety guidelines should be followed. In this part of the program, we'll identify some of the basic safety considerations that apply to straight ladders, extension ladders, and step ladders. We'll also look at how to select and use the proper type of ladder for a job. Ladder safety begins with choosing the proper type of ladder for the job. A number of basic factors should be considered when a ladder is selected. One of the first things to consider is how long the ladder must be to reach the area where work is to be done. All types of portable ladders have length limits. For example, step ladders can't be any longer than 20 feet. Plus, the recommended highest standing level of a stepladder is less than the ladder's total length. The recommended highest standing level is the vertical distance from the uppermost rung or step that the climber should use to the horizontal plane of the ladder base support, with the ladder properly positioned. So, make sure that the ladder you choose is long enough to allow you to safely reach the work area. Another factor to consider when you're choosing a ladder is what kind of ladder is best suited for the job. In other words, should you use a straight ladder, an extension ladder, or a step ladder? Often, determining the kind of ladder to use depends on whether the ladder will be leaned against a structure or if it needs to be freestanding. Determining how much weight the ladder will need to support is also important. Ladders are rated to support different amounts of weight, so you have to know the total amount of weight that the ladder will need to bear, which includes the weight of the person climbing the ladder, plus the weight of any tools and supplies that the person might be carrying. The material that the ladder is made of must also be taken into consideration when a ladder is selected. For example, metal ladders aren't suitable for jobs near electrical lines. Fiberglass or wood ladders are a better choice, since fiberglass and dry wood won't conduct electricity. Once a suitable ladder has been selected, it can be inspected and put to use. To get a better understanding of how a ladder should be used, we'll watch a worker use an extension ladder to reach a work area near a building's roof. Many of the basic guidelines that apply to using an extension ladder are the same as those that apply to a straight ladder. After determining that a fiberglass extension ladder is best suited for the job, the worker lifts the ladder from a storage rack so that he can inspect it for any obvious problems. He checks the ladder's rungs and rails, and he makes sure that the rope that's used to raise the movable section isn't worn or frayed. He also checks the rung locks to make sure that they're working correctly, and he verifies that the safety feet are in good shape. After he finishes the inspection, he carries the ladder to the work area. Along the way, he's careful not to hit anyone or anything with the ladder. Ladders can be heavy and awkward to carry. Sometimes it's necessary to get help carrying them. As the worker positions the ladder at the job site, he makes sure that the feet are securely set and that the narrow section of the ladder is at the top. He adjusts the length of the ladder from the bottom, where he can clearly see the rung locks. One of the most important rules to remember when you're using a straight ladder or an extension ladder is to maintain the correct ladder angle. We can see how to establish that angle using this illustration. When a ladder is placed against a wall or other support structure, the distance between the wall and the base of the ladder should be 1/4 the working length of the ladder. The working length is the distance between the base of the ladder and the point where the top of the ladder makes contact with the wall. The working length is measured along the ladder's rails. If the base of the ladder is placed too far from the wall, the ladder could slip out from under you. If the base is placed too close to the wall, there's a chance that the ladder could tip over backwards. With the ladder in place, the worker makes sure that he has all the necessary tools for the job. He carries the tools in a tool belt to keep his hands free for climbing. Then he slowly climbs the ladder, using both hands to hold on to the side rails or rungs. He keeps his body close to the ladder so that he doesn't tip over backwards. In this case, the worker will perform the work from the ladder. If he needed to step off of the ladder onto the roof, he'd have to make sure that the ladder's side rails extended beyond the top of the roof by at least 36 inches. As he performs the work, he's careful to maintain his balance and not reach or lean too far to the side or back. If he needs to move the ladder, he'll climb down first, then move it. When he finishes the job, he climbs back down the ladder, again using both hands on the side rails or rungs. He doesn't slide down the ladder, and he doesn't turn around to climb down. He then lowers the ladder, checks it to make sure that it's clean and in good condition, and returns it to its proper storage place. A so-called fixed scaffold is basically a temporary elevated steel framework that's assembled on a job site and used to support personnel and materials for construction and maintenance work. A number of different types of fixed scaffolds are available. One type is a tubular welded frame or tubular buck scaffold. It consists basically of prefabricated end sections that are connected with diagonal cross braces. Another type is a tube and clamp scaffold. It consists of individual vertical posts, horizontal members, and diagonal braces that are fastened together with clamps. Still another type is a locking ring or systems scaffold. It consists of individual components that are fastened together using locking rings and end connectors. Scaffolds are classified by the weight that they're designed to support. The design capacity of a scaffold is based on the total weight of all loads, including the weight of the working load as well as the weight of the scaffold. Three basic scaffold classifications are heavy duty, which is designed to carry a maximum load of 75 pounds per square foot; medium duty, which is designed to carry a maximum load of 50 pounds per square foot; and light duty, which is designed to carry a maximum load of 25 pounds per square foot. Scaffolds are designed and built according to strict safety standards. In fact, on many sites, scaffold builders are required to be certified according to company policies and procedures. But there are inherent dangers associated with working above ground level, and scaffold components can weaken or become damaged over time. Because of these concerns, some basic safety guidelines should be followed when any type of scaffolding is used. A systems scaffold is a common type of scaffold that can be assembled on a job site to form a rectangular framework capable of supporting personnel and materials. Basically, a systems scaffold consists of individual poles or legs that serve as vertical posts, horizontal members that connect between the vertical posts, and diagonal braces that connect the vertical posts and horizontal members to strengthen the scaffold. Many of the other components are the same as those for other types of scaffolding. While the exact procedures involved in erecting a systems scaffold can vary slightly, most of the basic steps are the same. The procedure we'll watch is typical, but you should always follow the guidelines established by the scaffold manufacturer or by your company. Before any scaffold is erected, there are some basic preliminary steps that should be done. One of the first steps is to carefully examine the work area for hazards in order to determine where to place the scaffold. You should also estimate how high the scaffold needs to be built, so you can determine how many components will be needed. Another preliminary step is to carefully inspect all scaffold components before they're used. Components that are excessively dirty or damaged may have to be cleaned or discarded. Let's watch these scaffold builders erect a systems scaffold using the components they've gathered. They start by placing wooden boards called sills on the ground where the scaffold legs will be located, and then placing a base plate with a screw jack on top of each sill. Next, short vertical posts called starter collars are placed on top of the screw jacks. The builders have added a connector called a coupling pin to the top of each starter collar so that other vertical posts can be added later. Then, the first of the horizontal members are connected between the starter collars. The horizontal members are secured to the starter collars by driving in wedge pins on the end connectors. This locks the end connectors of the horizontal members onto the locking rings of the starter collar. If the scaffold isn't level, the builders adjust the screw jacks as needed to make it level. They check each horizontal member this way until the lower framework of the scaffold is level. Then they nail down the base plates of the screw jacks to the sills to secure them. With the lower framework in place, the builders next install vertical legs over the coupling pins in top of the starter collars. The coupling pins have spring-loaded pins that lock the vertical legs and the starter collars together. In the next step, the builders install horizontal members to connect the vertical legs. These members are secured, just like the lower members were earlier, by driving in a wedge to lock an end connector over the locking rings on the vertical leg. Once the horizontal members are in place, ladder sections are added and secured to one of the vertical legs so that the workers can gain access to the upper part of the scaffold. A tag on the ladder bracket warns people that the scaffold is unsafe for use at the present time. A few scaffold planks are placed across the upper horizontal members at this point to give the builders a place to stand so that they can safely continue erecting the scaffold. Then a horizontal member is added between two upper vertical legs to provide a place for the builders to attach their fall protection equipment. The next step is to position diagonal braces to support the vertical legs and strengthen the scaffold. The vertical legs are plumbed by using a bubble level and sliding the connector of the diagonal brace up or down the vertical leg as needed. Continuing with the assembly, the builders add the remaining vertical legs to the scaffold. Then they install the horizontal members that will serve as the supports for the scaffold floor. After the final section of ladder is attached, planks are added to form the scaffold floor. Once the floor is in place, 2x4 toe boards are attached on all four sides of the scaffold. Then horizontal members are attached to the vertical legs above the scaffold floor to serve as guardrails. One member acts as an upper guardrail and the other one acts as a middle guardrail. Keep in mind that if people are going to be working or passing underneath the scaffold, a screen would need to be installed between the toe board and the middle guardrail. To complete the erection procedure, the builders use wire to secure the scaffold floor and toe boards to the framework. The crew chief then attaches a green tag to the scaffold to indicate that the scaffold is ready for use. After a scaffold has been assembled and inspected, it can be put to use. But it's important for workers to continue to inspect scaffolds while they're in use to make sure that they remain in good condition. It's also important to follow some basic safety guidelines when you use a scaffold. For example, always use both hands when you're climbing a scaffold ladder, and be careful when you're entering or leaving the work platform. Don't jump onto the scaffold flooring, since there's always the possibility that a plank could be loose or break. Also, avoid overloading a scaffold. Always follow the manufacturer's recommendations about safe working load limits. Finally, never use ladders or makeshift devices on top of a scaffold to increase the height of the work platform. If you need more height, add on to the scaffold. The disassembly of a system scaffold is basically the reverse of the assembly procedure. First, the scaffold tag is changed to indicate that the scaffold is unsafe for workers. Then the toe boards are removed from all four sides of the scaffold, followed by the upper and middle guardrails, which are removed by prying open the wedges that were driven in during the assembly. The scaffold flooring is removed next. Then the horizontal members that served as the floor supports are removed, along with the upper vertical legs. Next, the diagonal braces are removed from the vertical legs, and the ladder is taken off. The horizontal members that were connected to the midpoint of the first set of vertical legs are then taken down, and the vertical legs are lifted off of the starter collars. Once the lower horizontal members are removed, the starter collars are lifted off of the screw jacks. The screw jacks and base plates, along with the wooden sills, can then be removed to complete the disassembly. A tubular welded frame scaffold, which is sometimes called a tubular buck scaffold, is one type of scaffold that can be used to support personnel and materials. Basically, a tubular welded frame scaffold consists of prefabricated vertical end frames, or bucks, and diagonal cross braces that fasten between the frames. Horizontal members are attached between the upper end frames to serve as guardrails. Access to the top of the scaffold is provided by a ladder that's built into the vertical end frames or attached to them. Most of the remaining components are similar to those found on other types of fixed scaffolding. Many of the steps involved in erecting a tubular welded frame scaffold are similar to those used for other types of fixed scaffolds. For example, once it's been determined where and how high to build the scaffold, sills are placed on the ground where the scaffold legs will be positioned, and screw jacks with base plates are put on top of the sills. Then the vertical end frames are lowered onto the screw jacks. Cross braces are then connected between the two end frames to strengthen the scaffold. At this point, a bubble level is used to level and plumb the framework to ensure that the scaffold will be stable. And the base plates are nailed to the sills. The first section of the scaffold ladder is then put in place, and a scaffold plank is laid across the tops of the end frames so that the builders can assemble the next level. The assembly procedure is basically repeated at this point. Two more vertical end frames are placed onto coupling pins in the lower end frames, and each frame leg is secured with a locking pin. Then cross braces are added to stabilize the upper end frames. The next step is to insert vertical guardrail posts into the tops of the upper end frames. Then scaffold planks are added to create the work platform, and another section of ladder is attached. Toe boards are then added on all four sides of the scaffold floor, and upper and middle guardrails are connected between the guardrail posts. To complete the scaffold erection, the builders use wire to secure the toe boards and flooring planks to the scaffold framework. Then they attach the final section of ladder to a guardrail post and install a green tag to indicate that the scaffold is safe to use. The proper care and use of a tubular welded frame scaffold is very similar to other types of fixed scaffolds. For example, the scaffold should be inspected before each use to ensure that it remains in good condition. Also, workers who use the scaffold must follow the same basic safety guidelines that apply to other types of scaffolds. The disassembly of a tubular welded frame scaffold is basically the reverse of the assembly. After the green tag is removed to indicate that the scaffold is unsafe for workers, the toe boards are removed from around the scaffold flooring. Then the upper and middle guardrails are removed, along with the guardrail posts. The upper sections of the ladder are then disconnected, and the scaffold flooring is removed. Then the upper cross braces are taken off, and the upper end frames are lifted off of the lower end frames. The lower cross braces are removed next, along with the last section of ladder. Finally, the lower end frames are lifted off of the screw jacks and base plates. The screw jacks and base plates are then removed from the sills, and the remaining components are returned to their normal storage area. A pneumatic scaffold is a type of portable lifting device that uses pressurized air to raise and lower a work platform. Pneumatic scaffolds are often used in cramped work areas or in areas where electric lifts or gasoline-powered lifts aren't permitted. In this part of the program, we'll look at some of the basic features of a pneumatic scaffold, and we'll see how the scaffold is used. Here's the pneumatic scaffold that we'll use for our discussion. It has a work platform, or floor, for the worker to stand on, and a protective cage to prevent the worker from falling off. A pneumatic hoist mechanism is used to move the scaffold up and down a cable. One end of the cable is reeved around a drum inside the hoist mechanism, and the other end is attached to a beam or a similar support overhead. The hoist mechanism is controlled by a hand lever that regulates the flow of compressed air, and by a directional control valve that has three basic positions: up to raise the scaffold, down to lower the scaffold, and lock to hold the scaffold in a particular position. The scaffold also has an emergency or secondary brake mechanism to lock onto the cable if the scaffold moves down the cable at too fast a rate. A manual cranking handle is available in case the hoist mechanism fails, and the scaffold has to be manually raised or lowered along the cable. The airline oil system has two vessels. One vessel is the oil reservoir. It displays the oil level in the system. The other vessel is a condensation trap. It removes moisture that could corrode components in the air system. Before the scaffold is used, the moisture should be drained from the vessel by depressing a valve stem in the bottom of the vessel. The safe operation of a pneumatic scaffold depends largely on how the support cables are rigged overhead. Different methods can be used to rig a pneumatic scaffold, depending on the exact type of scaffold and where it's being rigged. Always follow the manufacturer's guidelines for rigging a pneumatic scaffold, and be sure to attach a safety line near the location of the cable attachment. Before a pneumatic scaffold is used, it should undergo a quick inspection of all the major components. This inspection should include the airline oil system, as well as all the basic controls and safety features. The hoist cable should be checked to make sure that it's properly reeved around the drum in the hoist mechanism, and the cage and work platform should be visually inspected for damage or deterioration. This operator has completed the basic checks, so he attaches a fall protection line to a rope grab on the safety line that's connected overhead. Then he sets the directional control valve to the up position and lifts the hand control lever for the hoist mechanism to start the flow of compressed air through the system. As long as the operator keeps the control lever lifted, the hoist mechanism will pull the scaffold up along the cable. To lower the scaffold, the operator simply moves the directional control valve to the down position and lifts the hand control lever. This basically reverses the direction of the hoist mechanism so that the scaffold will move down along the cable. Hydraulic scaffolds are available in a variety of forms, but they all work on the same basic principle. A motor of some type powers a hydraulic pump, which, in turn, drives a hydraulic cylinder to raise or lower a work platform. In this part of the program, we'll examine the basic features of a hydraulic scaffold, and we'll see how the scaffold works. Here's the hydraulic scaffold that we'll use for our discussion. Among the major components of this scaffold are a floor or platform for a worker to stand on, and a cage to prevent the worker from falling off the platform. The work platform is attached to an upright or mast that's divided into different sections so that it can basically telescope up and down. A battery supplies power to an electric motor, which drives the hydraulic system and enables an operator to raise and lower the work platform. Outriggers that are equipped with screw jacks are used to level and stabilize the scaffold while it's in use. The basic operating controls for the scaffold include a main on and off switch and an emergency stop switch, both of which can be activated from the ground. The hydraulic scaffold also has operating controls within the caged work platform area. These controls include an emergency shutoff switch and an enabling switch, which is used together with either an up switch to raise the work platform or a down switch to lower the platform. Let's watch as this worker uses the hydraulic scaffold. He starts by turning the screw jacks on the outriggers to level the scaffold. He can verify that the scaffold is level by checking a bubble level on the scaffold's frame. Next, he does a walk-around inspection of the scaffold's major components. He looks for any obvious damage or excessive wear. When he's ready to use the scaffold, he places any tools or supplies that he'll need on the work platform. Then he makes sure that the emergency stop switch is released, and he sets the main on and off switch to on. Next, he enters the caged work platform and attaches a fall protection line to one of the bars of the cage. He then makes sure that the emergency shutoff valve is released, and he uses the enabling switch along with the up switch to raise the work platform. As the scaffold moves upward, the worker is careful to keep his entire body within the caged area of the work platform. When he reaches the work area, he releases the up switch to stop the scaffold. He then performs the necessary work from the platform. When he's ready to come down, he presses the enabling switch and the down switch on the control panel. This lowers the scaffold to ground level. He then exits the caged work platform and sets the main switch to off.